Okay, after discussing vectors, now we're going to look at projectile motion. Projectile motion can be something as simple as this ball here bouncing up and down in the path that the ball takes while it bounces. Or it could be launching a projectile like shooting a basketball through a hoop. But projectile takes that parabolic motion. So 2 dimensions of projectile motion, and we'll talk about some things to think about, okay? First off, you have your velocity. You have an x velocity at the start. You could have a y velocity. In this case, you don't because you're launching horizontally. But the y velocity will continue to increase just like an object in free fall. But the x, as you can see from the vectors, stays constant. Now, what causes the object to gain speed as it drops? Obviously, we can look at the resultant velocity in the middle here for each of these and know that it's going to be gravity that does this. So if we're doing a horizontal launch, okay, velocity in the y will increase, which makes total velocity or the object's velocity increase, but the x velocity always stays constant. And this idea of constant x velocity is very important when we talk about projectile motion. Now let's look at an actual launching of a projectile similar to what we're going to do with the trebuchets. You have your initial velocity of launch. If you know the angle, right, you can find your components using vector math. As we go up, the x component stays constant, but the y component gets smaller because gravity is going down. At the very top of our projectile motion, okay, our y velocity is 0, so all we have is horizontal velocity, which is the same as the x velocity as we started. Then as we go down, it looks just like the previous example. Your x and y, your x will stay constant, your y will increase, which will increase the velocity of the object. Now, what we should expect to see without air resistance is that these velocities, as long as they're on the same plane, will be exactly the same, where it takes off and where it lands. Same thing with our components, without wind resistance. So here's something to think about. You got a child in a car, and the cart and the wagon's moving this direction. If a child throws an apple upward, where will it land? And this is something you'll say, well, land behind the wagon, in the wagon, or in front of the wagon. The big thing to say here, if air resistance is neglected. If there's air resistance, obviously it'll be different. But if there is no air resistance, because the cart's moving forward, there is an x component to the velocity. The y component is what the girl throws it up with. But what's going to happen is, since there's an x and a y, it's going to have a velocity that goes out, and what should happen without air resistance is it should land right in your hand. So, be something to test. Obviously, it's hard to do without air because we die, but that is something that is a trick question that you could see on the AP test. General kinematic equations for constant acceleration. You know these 3 equations. Hopefully, use them a lot. If we take the x and just change it to y, we can find vertical. Okay. Now we can simplify these equations. You know, you don't have to do this. Obviously, that's entirely up to you. But if we make acceleration in the x 0, okay, we take out this, which means that's our equation. We take out this, which makes this equation, and we take out this, which means our initial and final velocities are the same. Not very useful in the x. So in the x, we really don't use this equation, but in the x, we can use these 2 equations. Okay? And that's good to know, because x velocity stays constant. Now, when the y, okay, we know what acceleration is. So we just do some substitution here, and you can see we put g in for our acceleration in all these equations. So not much change in the y. But in the x, definite change, because acceleration is 0 in the x, which makes the math easy when we talk about the x. So, projectile motion, definitely read, definitely draw, okay? Choose a coordinate system, decide on the time interval, okay? And here's the key point. The time interval is the same in the x and y. So if you know the time in the x, you can know the time in the y. So as you break it apart into x and y coordinate system, understand that. List known and unknown, things we always know, okay? Acceleration in the x is 0. Y is going to be g, okay? And Vx is always constant, and that Vy is 0 at the highest point. These are things that if you think about might make the math easier for you when you solve problems. And then think about your equations, okay? We'll do quite a few sample problems between here and the next video just so you can see some different situations. But that's the steps to take. So, here we go. Diving off a cliff. A stunt driver on a motorcycle speeds off a 50-meter high cliff. How fast must the motorcycle leave the cliff to land on the ground level 90 meters below from the base of the cliff where the cameras are? Ignore air resistance. You always see this, but we can also always assume it. So the first thing is we know we're going off horizontally, okay? So there's our picture. I'm making right positive and up positive, okay? So anything down and to the left will be negative. Now I want to think about everything I know, okay? So let's talk about in the x. What do I know? Well, my velocity in the x is what I'm going to be solving for, okay? Because we want to know how fast the motorcycle must leave the cliff top. My x distance, okay, my x distance is going to be what we see here, and since that's to the right, there's 90 meters. My acceleration in the x is always 0. I definitely don't know time, okay? And then my initial position, because we're starting from here, I can also say 0 meters. Now for the y, my y velocity and x final velocity will be the same as my y, okay? My y initial velocity is 0. Since we're going horizontally, there is no y velocity. My distance in the y, when I'm looking here, this is going to be 0, my initial position, okay? My initial position will be 0. My final position will be negative 50 because I'm going down. My acceleration is negative 9.8. Assume Earth unless you're told otherwise. Don't know my time. And then my final velocity is obviously something I don't know either, but I can solve for. So the question is, how do I get initial velocity of x? And so we have to think about equations, okay? The first step is that I can find time. And the key to solving projectile motion is if you can find time early, then you might be able to avoid doing a lot of work later. So how am I going to find time in the y? Well, I look through my list of equations, and I'll let you do that. I'm going to go ahead and put my equation down right here. My initial position 0. My initial velocity 0. So I'm going to take those out of that equation, and I got negative 1/2 gt squared. Okay, I know my final position is negative 50. Negative 1/2, negative 9.8, t squared. Okay, actually positive 1/2. It's going to become negative number. So I do all this math, I take the square root, and my t turns out to be 3.19 seconds. Now that's key because if I know my y is 3.19, I also know my x is 3.19. So if I get them both, now I know my time in the x. Now I look at my equation to find initial velocity, and that has been really made easy. My velocity in the x times time, because I have no acceleration. So my distance is going to be 90. I don't know Vx, but I know my time is 3.19. So now my initial velocity, again, doing the math, 28.2 meters per second. And I've solved that. Again, the key to this, find time. Let's look at another one. Kick football leaves the ground at an angle 37 degrees with a velocity of 20 meters per second, as we see in this picture. Calculate the maximum height, time of travel, and how far away it hits the ground. All right. Assume the ball leaves the foot at ground level, okay, and ignore air resistance and rotation. So we're not getting anything fancy into this. So I look here, okay. My initial velocity is 20 meters per second, but my angle's 37 degrees. So again, x and y. Let's see what I know. All right, my initial velocity I can find. Okay, all I'm going to do is do some trig. So in the y, it's going to be 20 times the sine of 37. And in the x, it's going to be 20 times the cosine of 37. So I do these calculations really fast, and in the x I get 16 meters per second, and in the y I get 12 meters per second. Would you like what numbers work out like that? So I have 16 and 12. It's a nice 3, 4, 5 triangle. Okay. Now my next step is I want to see the max height. At max height, what do we know? Well, we know our y velocity is going to be 0. Okay, so if our initial is y and our final in the y at max height is 0, okay, then I can find my max height because my acceleration is negative 9.8 and the x at 0. My velocity stay constant in the x, so and then my positions, okay. To find our y position, we know we start at 0, and our initial position in the x is 0. Our final position in the y, height-wise, we don't know, and our x final position, we don't know either. That's our range. So we're solving for this. Ooh. And we're solving for this, and then we want to find time, and time is the last thing we want to find, which will be the same for both. So let's find our height. Okay, so y is initial velocity times time plus 1/2 at squared. I don't know y. My initial velocity in the y is 12. I don't know time. 1/2 negative 9.8 t squared. So my issue is I got to find time, which is okay because what we can do is we know time when we do some thinking with the equations is initial velocity divided by g. And this is a very useful equation when we want to find time quickly. So initial velocity in the y is 12, and we divide it by 9.8. Our time is going to be 1.22 seconds. So if it's 1.22 seconds, I then substitute that in for t here, and I find my height to be 7.35 meters. So 7.35 meters is how high my object gets. Now to find the time it takes, the total time, I can very quickly know if it's 1.22 to get to here without air resistance, it's going to be 1.22 times 2. So 2.44 seconds is my total time. And then how far away from the ground it hits. I go to this equation. Okay, since there's no acceleration, all right, it's velocity in the x times time. And to find my x distance, initial velocity in the x is 16. I'm in the air 2.44 seconds. When I multiply all of that together, you get approximately 39.2 meters. So, first step, things to understand, remember, at the very highest point, y velocity is 0. If I find time for half of it, if you double it, that'll be the time for the whole trip. And then you can use that time to solve for x. When you're in x, remember, it's a very easy equation. But you have to find time first.